right, so I'm really pleased to have with us today Dr. Sarah Scoles. She got her undergraduate degree in astronomy from Agnes Scott College, and then she went on to Cornell to do her graduate work in fiction writing. So she's going to be a really unique talk for us today. She has been published in everywhere from the New York Times to Scientific American to Wired to The Atlantic, writing about all sorts of things, including life on Mars, now life on Venus, and various other topics such as sexual harassment. She's also published 2 books, one of which is unfortunately in my office, and the other one is here, right here. Oh, it's backwards. It says they are already here. This one's about UFOs. This is the new one. Her other one is called Making Contact, and it is a biography of Jill Tarter, who the movie Contact is based on. And I have that in my office if anyone wants to borrow it or support a writer and buy it. And so I first met, well, I've never actually met Sarah. I first got in contact with Sarah when I read one of her articles in The Atlantic about 5 years ago. It was on sexual harassment. I thought it was a great article, and I emailed her. And just out of the blue, I looked up her email and I wrote her and I said, "This is such a great article." And we've basically kept in contact ever since then. And so I'm very pleased that she is here joining us. It's kind of a lesson for all you students out there about how to expand your network. Just do it. Just email someone and tell them you like their work, and it works. Okay, so here we are to learn all about the extraterrestrials. Thank you, Sarah.
Yes, thank you, Allison. I will always return everyone's emails, so hit me up. Yes, okay. Awesome. So today I'm going to be talking about some of the false positives in the history of SETI, the search for extraterrestrial intelligence, times we've thought we found aliens and actually had failed to, as, spoiler alert, we have always failed to so far in the past, and then hopefully some scientific lessons that we can take from those and carry into any field, not just the search for aliens. So are we alone or are we not alone? It is a question that humans have had ever since they realized the night sky showed them planets within our solar system and stars much farther away that might have their own nice planets for aliens to live in. Some people find comfort in the idea that we're the only ones out there, special little beings in the vast and unfriendly cosmos, but others find that idea deeply disturbing or frustrating, because the universe, as we know, and by its very definition, is very big, bigger than anything else. And to think that in all those many, many light years, we are the only sentient, talkative beings out there, doesn't feel great all the time. And as Carl Sagan wrote in Contact, as you see on this slide, it seems like an awful waste of space if it's just us. And there are reasons for thinking that the universe might be home to intelligent life besides just its sheer size. In the past few decades, as I'm sure you all are well aware, we've confirmed thousands of planets outside the solar system, and astronomers estimate that at least in our galaxy, there are billions of worlds Earth size, and that is a lot of prime real estate. And kind of second, in the same decades-long period, scientists have discovered Earth life living in some deeply uncomfortable places. Like this thing that we were actually just talking about right before the presentation started, the tardigrade. It can survive in the vacuum of space without water, hundreds of degrees below zero, with no food for 30 years, which is longer than humans used to survive, period, back in the cave days. And there's also extreme life in boiling hot ocean vents, totally salty lakes, radioactive waste, acid. Life seems to pretty much be everywhere on Earth. Which means it's not so weird to think that there might be life on planets elsewhere. After all, if it can occupy so many weird niches here, seems pretty feisty and resilient, right? As I'm sure you are also all well aware, the Kepler Space Telescope turned on in 2009 and stared at one spot in the sky to find out how many planets were there, and then use that number to kind of estimate how many others might be out there. And the results kind of wowed astronomers who not very long ago, just a few decades, weren't actually sure that any planets existed beyond the solar system. There was a period of time where people actually thought it might be quite hard to form planets. But now we know for sure of thousands, and we estimate that there are billions more, including lots of rocky planets right here in our galaxy. And so for all those reasons, scientists have more reason than ever to hope that the answer to "are we alone?" is nah, probably not. And the scientific quest to answer that question has a name: SETI, the Search for Extraterrestrial Intelligence. And today in modern science, that means a really specific thing: searching for extraterrestrials who have technology, can use that technology to send a signal that we can receive with our technology. If they like to keep quiet, if they were happy in some kind of like bizarro Stone Age, or they were alien dolphins who just liked to play around in exoplanet oceans and didn't build electronic tools, current SETI efforts wouldn't have a chance of finding them. And in the past, and largely also in the present, astronomers have mostly focused on looking for radio signals from ET. So I've heard some SETI astronomers describe it as not ET phone home, but ET ham home, which might be too corny for a joke. Since it's Zoom, I can't tell if anyone laughs at it or not. But the very first real SETI experiment happened in a place called Green Bank, West Virginia, where I actually used to work. I used to run science camps there when I was first out of graduate school. And this is the birthplace of US radio astronomy. And it also lives in a place called the Radio Quiet Zone. Maybe some of you have been there, but humans aren't actually allowed to use many of their technological devices: cell phones, microwaves, Wi-Fi, electric fences, things like that, all put out radio waves that frustrate the astronomers' efforts. And so in a 10-mile radius around the observatory, they're actually banned. But in 1960, when the observatory was just getting started, a young scientist named Frank Drake, who is in this picture, undertook a project called OSMA, in which he used the 85 telescope that is in the background of that picture to look at two stars that were kind of like the sun, called Tau Ceti and Epsilon Eridani. And this was the very first SETI project, and it had a false alarm very early, which immediately taught the scientists who were doing it some lessons. And I actually looked up Frank Drake's recollection of this event, and since he was there, he can probably say it better than me, so I'm going to read briefly his experience of that. So he said, "Whenever you search for extraterrestrial intelligent radio signals, you always feel at the beginning that the signal might pop up right away. During the first search, a few minutes went by, and then it happened. Wham! Suddenly, the chart recorder started banging off the scale. We heard bursts of noise coming out of the loudspeaker 8 times a second, and the chart recorder was banging against its pin 8 times a second. We had never seen anything like this before in all the previous observing at Green Bank. We all looked at each other wide-eyed. Could it be this easy? We thought the detection of a signal so unlikely that we had never planned what to do if a clear signal was actually received. Almost simultaneously, everyone in the room asked, what do we do now? Change the frequency? Well, the most likely source of a spurious signal was the Earth, and we could check that out by moving the telescope off the star and seeing if the signal went away. So we proceeded to do that, and as we moved off the star, sure enough, the signal went away. So we pointed back at the star. The signal did not come back. Wow. Was it really from the star, or had it been from Earth and had it turned off about the time we moved off the star? What did we do? Day after day, as we turned to Epsilon Eridani, we tuned to the frequency on which the signal had been heard. We listened for a half hour or so, and then we would go back to our frequency scanning. We also connected a second receiver to the simple horn antenna, which looked out of the control room and could pick up interference. A week went by, and the signal didn't return. We finally learned the truth about 10 days after that big day. Suddenly, the signals were there again, blasts of radio noise 8 times a second, coming in the 85-foot telescope. But just as strongly, they were coming in the little horn we had poked out the window. The signals had to be man-made radio interference. As we watched them, we saw them grow and fade as though they were being transmitted from a high-flying, passing airplane. So that's the end of Frank Drake's recollection. But it just goes to show that as long as there have been SETI searches, there have also been kind of aha, oh, but wait a second moments. And also the desire on some level, on the part of the scientists in this case, and also later on the part of the public, or both at the same time, to interpret signals that they're seeing as mysterious and interesting, and as maybe perhaps, wouldn't it be cool if it were aliens, even though there might not be enough evidence for that yet. I'm sure, I don't know if anyone watches Ancient Aliens, but this is that guy from there who is part of a meme that, you know, this talk is in opposition to the meme. He says, I'm not saying it was aliens, but it was aliens. And I'm saying, I'm not saying it, what am I saying? I'm saying it probably wasn't aliens. And I think what Frank Drake's first false positive teaches us is it's easiest to pick up our own technology, because in SETI, scientists are looking for alien technology, and especially at the beginning, they base their searches on the tenets of our own technology. And so we kind of, by definition, detected ourselves. And that's one reason astronomers put telescopes way out in the middle of nowhere in places like Green Bank, and why radio frequency restrictions are good for SETI and for astronomy, because our technology is so powerful that it swamps natural signals and looks like what we might imagine an advanced civilization might create, and also just can totally drown out other sorts of observations. But it's easy with the hope I think we naturally have that we might find aliens someday to interpret something that is anomalous as coming from them, especially if that's what we go in looking for, and to kind of keep going back to it with that hope, like Drake did over and over again, looking at that star. And that's good in one sense, because it's what's kept SETI searches going for so many decades, but it's also a good thing to keep in mind as a kind of a cognitive bias when we're interpreting. And so the second example I'm going to give actually jumps kind of way back in time, and shows that it is also easy to sense things that aren't even there because of the biases we go in with, and to interpret them based on that, and kind of superimpose the technology that we have at a given time in history and see it elsewhere, even when it's not there at all. And so this began a long time ago. I think it's pretty natural for our brains, and I'm sure it probably started before the story I'm going to tell. But this is an early story from before SETI as we know it even started. And so in 1877, Giovanni Schiaparelli, who was the director of the Brera Observatory in Milan, began mapping and naming areas that he found on Mars. And he saw these little lines crisscrossing the red planet and called them canali. I wish I had a better Italian accent, but I don't. And that that means channels, but it was mistranslated into English as canals. And when we have canals on this planet, it's because somebody built them. Ergo, someone or something's on Mars must have built these canals, is what some people thought. And that was in part because just a few years before, engineers had constructed the Suez Canal. And so humans were kind of primed to go see that kind of technology on another planet, and to think that maybe Martians had the same irrigation and transportation plans that we did. So in 1894, Percival Lowell, who was a wealthy astronomer from Boston, made his first observations of Mars from a private observatory that he built in Flagstaff, Arizona, Lowell Observatory. He'd heard about the canals, and he decided they were very real. He apparently had a lot of time on his hands and began to map them, hundreds of them. This is one of his maps shown on the screen. And he believed the Martians had built them to move water from the polar ice caps to the middle of the planet, which is quite the narrative to impose on what he was seeing. And so then in 1895, he published his first book on Mars with lots of illustrations of these canals that the little green men had made. And then he went on to publish 2 more books about it. His theories actually influenced H.G. Wells, the science fiction writer, who a few years later published The War of the Worlds. As you know, it wasn't meant to be. There appear to be 0 canals on Mars. And as a NASA historian said, most experienced astronomers never saw the Martian quote unquote canals, and for good reason. We now know they never existed. The network of crisscrossing lines covering the surface of Mars was only a product of the human tendency to see patterns, even when patterns do not exist, which I think is a lesson that we can carry forward into many parts of science, that's what our brains do, is they look for and find patterns, especially ones that we go in with some preconceived notions of because of what happens here on Earth. And I would add something that historians and kind of policy types call the modernity bias, which is to superimpose on whatever we're searching for, the particular technology that we have at a given time in history on something that we see in space. The next example that I have is pulsars. And these were partly discovered by an astronomer named Jocelyn Bell Burnell. Starting in 1965, Bell Burnell spent about 2 years physically building the Mullard Radio Astronomy Observatory. Together, she and 2 other students hammered 1,000 posts, strung 2,000 dipole antennas between them, and connected it all up with 120 miles of wiring cable. So I think we can all be grateful that whatever research looks like these days, it usually doesn't look like physically building your own telescope, but good on her for doing that. And the finished telescope covered about 4.5 acres. They started operating the telescope in July 1967, while the construction was actually still going on. And it was Bell's job to physically do the operating and then analyze the data, which came out in the form of chart paper with ink on it, if you can imagine. And it was nearly 100 feet of paper a day. And she soon learned to recognize what they called scintillating sources and human interference from our technology. But within a few weeks, she also noticed something odd in the data, which she called a bit of scruff, which are all these little pulses you see in this chart paper on the screen. The signal didn't look like a scintillating source or like human interference. And she soon realized that it was a very regular signal, consistently coming from the same patch of sky. At the time, no known natural sources would produce such a signal, and so Bell and her advisor began to rule out various sources of human interference, like other radio astronomers, radar being reflected off the moon, television signals, orbiting satellites, and even possible wonky effects from a metal building near the telescope. But none of these could explain what she was seeing. And what she was seeing was this series of sharp pulses that came every 1.3 seconds, which are those very regularly spaced things you see on the page there. And they seemed too fast to be coming from anything like any kind of star that anyone knew existed. And so Bell and her advisor kind of jokingly called this mystery source LGM-1, which stood for Little Green Man 1. It was obviously later renamed. But soon they managed to rule out extraterrestrial life as the source of the signal when Bell noticed another similar signal, this time a series of pulses arriving a little more quickly, 1.2 seconds apart, coming from a totally different part of the sky. And the lesson that I see here is that if you see one of something, it's an anomaly. And, you know, if it has intelligent looking characteristics, like if it's very squished in frequency, like something that would come from our technology, or if it comes very quickly, it's reasonable to put forward aliens as one in a set of other less fantastical hypotheses. But you should also keep looking, because if you see two of the same thing, especially in different parts of the sky, chances are it's not aliens who happen to have similar technology, even though they're separated by many light years, but it's a kind of new physical object that you didn't know existed, which is exciting in its own way, even if it doesn't look like this peace sign guy in the middle of this slide. And for the third example, I'm going to go much farther out in the universe, much farther away. And this one goes back to the 1960s, kind of the beginning of SETI as a field again. And in this time period, a Caltech radio survey had discovered this bright object they called CTA 102. And by March 1963, an astronomer named Martin Schmidt had discovered quasars, a new type of object, active centers of galaxies far away, where black holes were devouring material and putting out huge quantities of energy. But knowledge of that sort of object hadn't yet reached Russia. You know, it was the Cold War and there was no internet. And so astronomers there didn't consider quasars as a potential explanation for what CTA 102 was. And that fact kind of synced up with a different set of circumstances, which was later that year, an astronomer named Nikolai Kardashev wrote a paper about something he very modestly called the Kardashev Scale. And the Kardashev Scale says that there kind of tries to qualify hypothetical alien civilizations into three types. Type 1, where they can harness all of the resources of their own planet. We are not really even a full type 1 here on Earth. And then there's type 2, which can muster all the resources of their star. The most famous example of that kind of thing is a Dyson sphere, which is a hypothetical kind of megastructure that you would put around a star and channel all of its energy to your planet. And a type 3 civilization can control energy on the scale of its entire galaxy. And so once Kardashev had this scale, he pointed at CTA 102 and he said, you know, that maybe that is evidence of a type 2 or 3 Kardashev civilization. That seemed to be backed up in 1965 when another astronomer found that CTA's radio emission was varying, suggesting that perhaps some alien civilization was messing around with it in ways that were unimaginable to us. And all of those things kind of swirled together, and the astronomers actually made a public announcement in April 1965, causing a worldwide sensation. It made alien news all over the place. But this too was not to be. Not long after, a telescope in California called Palomar, which is an optical visible light telescope, shows that CTA 102 was just a plain old quasar. It was a good reminder that that physical mysteries sometimes, often, always so far actually, have physical and not biological explanations. And I still see this as kind of good news, even though we got fooled again, because SETI kind of keeps astronomers alert to the potential for these anomalies. When they discover something they can't yet explain, they can try to explain it through a non-alien means first. And then if that works, then congratulations, you discovered something cool and new about the universe. And if it doesn't, you can keep the alien hypothesis on the table, although probably it's good not to, issue a big news release about it until you're more sure. The next story is of a search that actually set out trying to find aliens, so like Frank Drake did, and it involves astronomer Jill Tarter and her team. For a long time, they were the primary SETI scientists in the US, and they had their own false alarm in the favorite place of this talk, Green Bank, West Virginia. And I actually wrote about this scene in the book, Making Contact, that I wrote about Jill and SETI. And I think I probably wrote about it better than I would relay it to you. So I'm just going to read some paragraphs of that. I was going to ask if it was okay, but you can't tell me because we're on Zoom, so I'm just going to do it. And a couple of terms. Project Phoenix is the name of the SETI Institute's SETI project that they ran for a number of years. And the Woodbury telescope is a telescope in Georgia that they used to look at the same stuff that Green Bank looked at the same time as kind of a double check, like, do they see the same thing or not? But problematically, it was broken on this particular day. So in the early hours of June 24th, 1997, Jill Tarter paced back and forth along the narrow tile of the Green Bank 140-foot telescope's control room. On one side of her, the control panels, which looked like they belong in a clunky 1970s starship, hummed. On the other side, the Phoenix computers churned a strange signal around their circuits. The telescope had zoomed in on the star YZ SETI, a dwarf star that regularly flared with bright bursts of radiation. But the equipment picked up more than those bursts. It also found a steady signal arriving at a particular set of frequencies that were equally spaced across the dial. It was just the kind of radio station type broadcast from space, from intelligent extraterrestrials, that Tarter had dreamed of, and exactly what they had designed their equipment to detect. Such a signal exists, as far as we know, only when someone creates it. Someone could mean either humans or extraterrestrials, though. So before Tarter could break out the champagne, she needed to make sure the team hadn't made the less monumental discovery of an airport radar or a North Korean spy satellite. Had the Woodbury telescope been working, they would have done the usual follow-up, seeing if the signal showed up the same there. Instead, they had to improvise. Tarter roused her colleague John Dreyer from sleep in the dorm, and together they commanded the telescope to move far away from YZ SETI to see if the signal disappeared. It did. That was a good thing, indicating that it was really coming from a single spot in the sky. When the telescope was pointed back on the star, the signal reappeared. They repeated the cycle multiple times with the same results. Then, at Dreyer's suggestion, she tilted the telescope just a tiny distance away from the star. The signal stayed just as strong. It didn't make sense, said Dreyer. If the signal were actually coming from the star, as the first sequence of tests indicated, it should have dimmed by a small amount in this new test. By then, it was late afternoon, and the star would soon set. Tarter debated calling another observatory located to the west, where YZ SETI would still be above the horizon. But other astronomers didn't like having their observations interrupted. What if they missed some truly exciting blazar blast or neutral hydrogen action because they had decided to check up on a dubious claim that ET had finally phoned home? Besides, Tarter didn't want to shout or even whisper about the potential phone call in public yet, not until they were sure. A false announcement could ruin them. Crying wolf never helped a struggling cause. That is, after all, the point of the fable. She had, though, called California, and her colleagues at the SETI Institute were watching a mirror copy of the Green Bank control room computers that sat in the lobby. When YZ SETI set, Tarter and Dreyer turned the Phoenix controls back to automatically search the next stellar targets rising in the east. They gathered up the log files and printouts from today's activities and headed off to dinner, with a growing sense of disappointment that this signal was not the one. Sometime during the day, the New York Times called Tarter's colleague, Science journalist William Broad wanted to know about this signal they were tracking down there in West Virginia. How had he heard about it, though, in those days before social media, when the team had locked themselves in the control room? It was a game of telephone. Broad was working on a tribute piece for Carl Sagan. He had just called Sagan's widow, who had talked to Tarter's assistant, who had told her that Tarter had delayed her homebound flight to, quote, take care of some business at Green Bank. In SETI, that's very suspicious. The scientist told Broad they would get back to him, and he probably thought he had the scoop on everyone else because of his fortuitous phone call. By the time Wisey SETI crawled above the horizon at 5 a.m. the next day, Tarter's perusal of the previous data and a bit of web searching had turned up a mundane match for their signal. The Solar and Heliospheric Observatory, SOHO, which is the picture on the right there, a satellite that takes close-ups of the sun that make it look alive and angry. The SETI Institute had found, once again, only evidence of humans. If the Woodbury telescope had been functioning, if the spacecraft had been orbiting Earth instead of the sun, this incident would have resolved itself right away. Instead, they had to learn a new lesson. If they ever did detect a communication from an extraterrestrial civilization, they would not be able to keep it a secret. The William Broads and New York Timeses of the world would find out fast, and this before Twitter. And I think that is a dynamic that I'm sure we all have seen play out on the internet among my people, the journalist jumping to call something aliens before we know anything about it. The next one is from the news headlines in the past few years, and it relates to Twitter and the internet, and how information about a potential discovery will spread faster than ever. There's a lot of conspiracy theorists out there who think that aliens are being kept a secret somewhere, you know, that's not the case, especially not with SETI people who I have spent enough time with to know that they would not be very good at keeping a secret. But this example is called Tabby Star, which you may have seen in the news starting 3 or 4 years ago, I think, under the headline Alien Megastructure. So we'll start with stars. They exist when planets pass in front of them, between us and them. They block just a bit of the light, kind of like if a friend walks in front of the TV while you're watching it. But stars are so much bigger than planets that they just block a small fraction of the light. That's the kind of dimming that the Kepler Space Telescope looked for. But in March 2011, Kepler saw something different in front of a star that astronomers have affectionately called KIC 8462852. Something was blocking 15% of the light. To do that, the something, whatever it was, would have to be really huge. And on February 28th, 2013, it happened again, and this time it blocked 22% of the light. Just as a comparison, when Jupiter darkens the sun, it does so by just 1%. And the data also showed a bunch of confusing, smaller, irregular dips in brightness. So a group of citizen scientists, called the Planet Hunters were the first to notice these weird goings-on. When they saw KIC 8462852's weird behavior in the Kepler data as they were searching through it, they alerted an astronomer named Tabitha Boyajian, who was a member of the Planet Hunters science team. She looked at it, she wasn't sure what she was looking at, but she soon brainstormed some astronomical explanations, which she detailed in a discovery paper that she subtitled, Where's the Flux? You might notice that that makes the acronym WTF, and so it became known as the WTF Star. The explanations she gave have included a fragmented planet, a swarm of comets, a slowly cannibalized hot gas giant, and more recently a giant ring of dust. But there was another explanation. Her fellow astronomer Jason Wright, who's at Penn State, said maybe it was an alien megastructure, kind of like the Dyson spheres that I mentioned a while ago. Some huge thing orbiting the star that aliens had built, potentially going between us and it. And Jason Wright happened to mention this explanation in an interview with The Atlantic. And when that article went online, people freaked out. The part about the aliens was all anyone noticed. And at first, Tabitha Boyajian was reluctant to embrace the idea, but soon she saw that the public was so fired up about it, and also that astronomers couldn't dismiss it, that she decided to embrace it. And she started a forum for discussion and a Kickstarter to fund further observations because, you know, you all know better than me, it's hard to get telescope time. But if she could buy some at a private observatory, then she could keep kind of a constant eye on what was going on with the WTF star. And, you know, I'm sorry to say, we have not determined that this is aliens. Lately, the foregoing hypothesis is that dust and debris from something like a disintegrating moon could be blocking the light. That's cool, maybe not as exciting as aliens. Still, this is a star system that was a mystery that is not totally solved, and it's kept astronomers busy thinking for years, which I think is a good thing. And it has shown yet again that being kind of alert to anomalies, like SETI helps us be, helped astronomers find something new and weird, something they didn't know could happen, which is exciting and good for science, even if that new and weird thing isn't that we are not alone in the universe. And my next example is a modern case of us being fooled in the kind of really old school ways, kind of the same way that Frank Drake and the SETI Institute both were fooled by humans' own very non-alien technology. So a few years ago, maybe around 5 years ago, a group of astronomers made many, many headlines after giving a presentation about a, quote, strong signal in the direction of HD 164595, which is a sun-like star about 94 light years away. They were using the Rattan 600 telescope, and they picked up a blast of radio waves that was 4.5 times the background static. They, kind of like Jason Wright and Tabitha Boyajian, put maybe aliens forth as a potential hypothesis among many. And that presentation that they made began circulating kind of, I think, just through emails and private channels among astronomers as a slide deck. And then the website Centauri Dreams got a hold of it and wrote about it as an interesting SETI candidate, meaning, you know, perhaps it came from an alien civilization. That kicked off a storm of headlines among my people, the media, speculating about these hypotheses. And there were dozens of articles all over the world about how maybe aliens have been discovered in Russia. But the problem was that there was very little evidence that that was even possibly the case. We couldn't tell where the signal was coming from because the field of view of the telescope was very wide, like the size of a pixel was very large, couldn't narrow down its location. We didn't know if the signal was narrowband, which is a hallmark of technology. It could have been human interference. We hadn't ruled that out. And in lots of other SETI type systems, the signal would have just been thrown out the window. Lots of SETI systems go back automatically to potential signals and see if they see them 3 or 5 times, and only then do they get flagged as a candidate. In this case, they looked at the star 39 times and only saw this 1 time. So this would have been just thrown in the trash other places. And also, no other telescopes got a look at it. There was no follow-up. And spoiler alert, they eventually just realized it was a military satellite. And in terms of lessons, if we're looking for life lessons from this, the ones I take is that even if there is literally no evidence that it is ET in any way, it will make some headlines and people will get excited because aliens are great, and that is true, but it doesn't mean we should be irresponsible about what we're saying. I think also it's important to remember that we still make the same rookie mistakes of not rolling out our own technology, just like we did in 1960, which was a very long time ago. And then finally, that seeing something once is not enough unless what you're seeing is encoded designs for a spaceship, like in the movie Contact. Someone was asking at the beginning of the talk, what happens is there a protocol for if we do see a positive signal, and there is. It goes by the catchy line concerning activities following the detection of extraterrestrial intelligence, and it has been presented to the UN Council on Outer Space, but has not officially been adopted, and its equally catchy nickname is the Post-Detection Protocol. So the first thing you're supposed to do according to this protocol is verify it with your own telescope and try to make sure that you look at every possible plausible physical explanation for what you're seeing, whether that's a natural phenomenon that just looks strange or human interference. Then you ask someone like the SETI Institute did in their observations, or thought about doing in their observations, to go see if they see the signal in the same place, doing the same thing, and also ideally if they agree with your interpretation that it couldn't possibly be just physical. And then if you get confirmation from somebody else's telescope, you get to send what is called an astronomical telegram, which goes out through the International Astronomical Union to kind of alert the whole community about what's going on, so that they can also have the opportunity to try to confirm it and confirm your interpretation. And once that happens, you are also allowed or supposed to disseminate it to the public, to the media, send out a press release, and the idea is also to coordinate in sending it out responsibly so that everyone can hedge what they're writing for the public appropriately. And step 5 is just my step they made up, because there are a lot of theories that they will try to hide it, but I promise that SETI astronomers would be more excited than anyone else probably to find a signal from aliens, and so they will not be keeping it a secret, and they are also semi-obligated to make the data public and to protect the wavelengths where the signal appeared so that everybody can keep gathering data on it independently. But that hasn't happened yet, has it? I don't believe that any such telegram has ever gone out through the IAU. And that is because even though humans have been at the SETI project for 60 years, we haven't made much progress, really. A, the universe is super big. B, we do not know how aliens, if they exist at all, might choose to communicate. Jill Tarter has this kind of pseudo joke she likes to tell, where if somebody asked her why they're looking at radio waves to search for radio alien broadcasts, she goes, it's what we know, it's what we know how to search for, it's what we can imagine they might be using. For all we know, they communicate using zeta rays. And then you, the listener, are supposed to go, what's a zeta ray? And she says, I don't know. And that is the point, that we look in radio waves, now we're looking some in lasers, we have some other creative ideas of how they might appear, but really we're just making it all up. It's all hypothetical and we can only guess. And as Jill Tarter likes to say, we reserve the right to get smarter and to adopt new search strategies as we think of them. But to she also is fond of saying, and I think a lot of SETI people are fond of saying, you wouldn't dip a glass in the ocean, come up with no fish, and conclude there are no fish in the ocean. But that is what some people do when they talk about SETI. Oh, we haven't seen anything yet, therefore there must not be anything out there. And it is true, there might not be anything out there, but we have not fully explored the ocean. In fact, Jason Wright, the guy who first proposed aliens for Tabby Star, calculated that we have done the equivalent of a hot tub's worth of the ocean, which is better than a glass, but worse than a whole ocean. So how will we know if we have taken a meaningful look at the alien ocean? And if you ask Jill Tarter, who's been at this for decades, she thinks that we should look at 1 million stars within 1,000 light years of Earth at every frequency between 1 and 10 gigahertz to do just a thorough radio survey, not even considering other wavelengths. And I made this beautiful pie chart of how good a job we've done, where the pink part, 99.959%, is what we have not done, and 0.041% is what we have done. And so clearly there's a lot more work, and surely some more false alarms in our future. But maybe someday there will be an actual alarm, and some lucky astronomer will get to send out that telegram. And in the meantime, as the past has shown us, being aware of and not just kind of tossing out anomalies in the data can help astronomers and physicists in their own data discover unexpected new objects on behavior that are interesting on their own, and that will also be useful for kind of evaluating future SETI alarms, because the more natural phenomena we know of, the more we can rule out when we see the next anomaly, whatever that is. And I think I have a few more slides I could go through, but I don't want to take up all the question time. So I think I will stop there and see if there are any questions. And then if there are not, I can do some slides.
Thank you so much, Sarah. That was wonderful. So folks, if you want to, using Zoom, go ahead and raise your hands. We can go ahead and start the question time. Yeah, question from Yoni.
Hi, great talk. Thanks for coming. David Kipping at Columbia had a paper out last year, I think, about discussing the statistical implications of when exactly life arises in the history of a particular planet, and when that life becomes sentient to the point where it can actually like communicate in like a SETI relevant way. Mm-hmm. Do you know if what the current status of like those sorts of considerations are in the SETI community, and whether that's sort of informing maybe where we look for life?
Yeah, I haven't read that particular paper, but what has been most interesting to me recently that seems to be going on in some of the literature is people from outside of SETI and the astronomical disciplines specifically calling into question a lot of the assumptions that astronomers have made about how biology and civilizations progress. I think there's a fairly strong contingent on the biological side that says that it is much harder than astronomers think to form life in the first place. And then on the kind of anthropologist side, like once you have an intelligent species, calling into question the idea that it would always progress forward toward technology, that both of those are our own biases in different ways. And so to me, the most interesting thing is seeing these other fields getting involved, and technically those are their specialties and not the specialties of radio astronomers who are good at telescopes and observations and engineering, and who I think maybe think it's a little bit easier for those things to happen. But do you remember what the paper's conclusion was by chance? You might not be allowed to talk.
Oh, sorry. No, my my audio cut out for a bit. Thank you.
Sure. Yep.
So we have a question from Ian Crossfield.
Hi, I was just wondering if, as a writer yourself, if you have any sort of general advice for scientists who are trying to communicate any of their results, whether SETI related or not, to the general public.
That's a good question. I mean, especially, I imagine if you are trying to communicate your results, you imagine that they, have implications and interest for the general public, and given that there is always the potential for a writer to overhype them or present them incorrectly, which we don't want and you guys don't want either. And so I think what I find really useful when I talk to researchers is to kind of start at the beginning, like how did you get this idea? How did the idea for whatever paper is coming out evolve as time went on? And then kind of taking the most salient and interesting conclusions and trying to imagine that you were explaining them to maybe like a lower level undergraduate who wasn't specialized at all, and just kind of taking it step by step. I mean, I know and I understand fully that when you're coming from the science side and talking to someone who's a writer or writing up your own research, that there is the fear that it will be overhyped or misrepresented or not as nuanced as you would want it to be. And I think that is fair, but I think you know, we want to write about it well and want to help you communicate it well. And so just yeah, I guess that's my answer. Kind of going through the process kind of helps give us a grounding in how it fits into the larger picture, and will help us understand the main conclusions well. Thanks for the question.
So I also had a question. I mean, this was a lovely sort of set of case studies of all the ways that we have not found aliens and how quickly that information got out there as well. You know, and for me as a scientist, that's extremely compelling, right? And so I'm wondering what your thoughts are with talking with folks, with interacting with folks. You know, how is this message sort of either not getting out, or what angle are folks coming from with sort of the conspiracy theory ideas that, that absolutely aliens are out there, right? And they are being hidden, and that this is something that, has happened despite all these various occasions when it clearly has not.
Yeah, I think partly the reason that conspiracy theories exist is because some of these things get out there and get misrepresented as, we did find an alien megastructure, or we did catch an alien burst. And so, when you kind of just hear that over and over again, it kind of permeates people's consciousness. I think that that scientists already know it's out there, and although in those examples no one was trying to hide it, when people later walk back from that, I think it kind of helps foster the mindset that scientists know these things and are keeping them from people. But I think, it's hard in my position too, because sometimes when something might be aliens, it's not right either to censor the idea that it could be, but it's very hard to present it as it could be without having people take it as an is, which I think, to take a recent example, finding phosphine in the atmosphere of Venus, which does not necessarily mean there are any aliens there, but that is one hypothesis among several for explaining what it's doing there. And even though, for instance, most stories that I saw were pretty responsible about saying, this could be a sign of life, but it is not necessarily. If I go talk to, my uncle about the Venus news, he's going to say, yeah, they found aliens on Venus. And so I don't know exactly what the solution is, except so I'm going to pivot like a politician to what the solution is not. But it does make me call into question the idea that a lot of SETI astronomers or astrobiologists have, that the discovery of alien life would kind of throw the world into psychological chaos, for better or worse. Like, it would either make us, unite, or have religious revelations, or all kinds of things. But it turns out a lot of people on the planet think we already have found alien life, and they're just kind of going about their lives, which I feel like we forget about a lot.
I'm going to ask a follow-up if there are no more other questions here. How do you think technology is helping versus hindering the development of these sorts of conspiracy theories? You talked a lot about sort of, how information spread even before Twitter, for example, and one sort of imagines that these days it's hard to have something happening without some number of witnesses, right?
Mm-hmm.
So what are your views on what role current technology is playing?
Yeah, I think that current technology obviously now allows news to spread faster. Like even if the New York Times guy who I mentioned heard about the SETI discovery early back in the late 90s or early 2000s, he heard about it without social media. He could have written about it for the New York Times. It would have taken a lot longer for that news to make it to my uncle than it would today when everything spreads like wildfire. And so I do think more people hear about things and then can also go off into their own discussion groups. And if somebody is already part of like a conspiracy theory mindset, chances are research shows that a lot of their social group is too. And then, the digital echo chambers we talk about for politics are also true of scientific or technological conspiracies, and people mostly hear the same takes that they have mirrored back from other people. But I think also because of that same technology, people forget about things equally as quickly, especially when we have so many other things going on right now. For instance, a pandemic, an election, civil unrest, things like that. Just like there's so many things that we have to hear about through all of these technologies that even big discoveries of potential aliens kind of are gone after a day or two. And so I think maybe actually I haven't tested this hypothesis. I can't test it, but I haven't researched this hypothesis. But I wonder if some of the earlier ones actually stuck around for people longer. That's a paper for an anthropologist.